So I tried to kind of do not too much slideware here, so we're going to talk during each one of these. But when I thought about this, I thought about, let me try to think about designing a network detection and response engine along with a network traffic analytics engine. And I want to think about those things that you would have to build into it. And I think about these problems as a lifelong engineer. I try to think about these problems, break it down into some areas, and then solve those individual problems. So I identified kind of three big things. First of all, speed. Our networks don't get any smaller, right? That never happens. A few years ago, we were happy with 1 gigabit. Now it's like we're looking at 400 gigabits when we really want to get to it. Don't need to go too deep into that. Sprawl is the other thing. It's no longer your on-premises. It's now 15 different cloud VPCs, or actually 15 VPCs. It's 15 different accounts on these things, and you're all over the place. You're in 3 different major cloud vendors. In addition, you're trying to logically separate out some of these areas. There's a difference between your ZMZ, and there's a difference between your production network, and there's a difference between where your employees are sitting on the network. So you want to have visibility into all of those. East-West is an area that is not often captured. East-West is a little bit different than North-South. North-South is probably going through your firewalls. You've got some controls on that. But the East-West stuff is really interesting too, and you often do not have as much visibility into that. Finally, thinking about security. IP never had any inherent real security policy or security properties to it. TLS is increasing in use. I don't need to belabor that point at all. We're all pretty familiar how that's happening. So we have some answers for that. So these are the kind of general problems that I wanted to kind of dive into. And I already mentioned the network detection and response category. The goals here are to make the detection, the investigation, and then the remediation, make those all really easy so that they just kind of pass through our system, and we can have a tier 1 guy or a tier 2 guy going through those in our SOC and getting these things remediated as quickly as possible. As a CISO, I think about one of my primary goals is mean time to resolution, mean time to detection, these sorts of things. These are the things I want to drive down. The network traffic analytics, the same thing. This is just understanding the network and then getting visibility into what the devices on the network are doing. I think these all make sense. I just wanted to lay out the goals right up front into what it was that we're trying to do here. So now this is a point where I break it down. And so we architected this for a few different ways. I want to start off, and we're going to talk a little bit, this is how it works. So we're going to talk a little bit about packet acquisition, how we get packets, because that's interesting in different locations. It's different in the cloud than it is on premises. The network metrics. This is things like packets per second. We'll dive into that. Records are an interesting thing. Records are essentially log lines. We'll go into it. Packets, it's always good to be able to pull. We already gave an exemplar of a use case, right? To say, I really do want to have some of these packets because maybe that's the only way that I have to recover something. I'm assuming they actually had some backups. It's just that they decided that it would be easier just to pull them from the packets than from the backups. Decryption of traffic. I mentioned the rise of SSL or TLS. We also have something that I'm pretty pleased with, being a lifelong engineer, is an event-based domain-specific language. We'll talk just a little bit about that. And then finally, I want to talk about the machine learning. And we'll probably spend most of our time there because, like I said, architecting it for privacy and thinking about the data that's going up, there's some really interesting aspects of that. So first of all, packet acquisition. This is pretty standard. You probably have this in your network today. It's TAP or a span, or often called port mirroring on the cheaper switches. Essentially, a copy of every packet gets sent off to some other device. And this is pretty easy to set up. We've had it set up in our network for a long time. What I want to point out here is we're not getting NetFlow. We can eat NetFlow if you want to send it to us. That's fine. But we much prefer the full packets. And the reason why is because we have our model is not based on store and process. Our model is based, many of the other, if you're familiar with Bro or Zeek, they have a store and process method where they essentially store the PCAPs on disk and then go back and process them later. From my many years of working with a load balancer company, that is a terrible way to do things because it's incredibly inefficient, right? What I want to do is I want to start pulling that metadata out of it as the packet comes along, and then I can ignore the entire body of the packet. I really don't care about the HTTP body in many cases. I may, but in most cases I can just drop that on the floor and continue on with continue on once I've gathered the metadata about what's happening. HTTP headers, prime example. It's easy to think about that way. So the key to speed is to process only the bytes you need. And then finally, just because most people ask about this when you start talking about packet acquisition, what's happening in the cloud. We do have a packet forwarder that will send us packets from whatever devices you choose to install it on, or Azure has a tap that they've been working on recently. So these are all possible ways to get packets. So let's talk about those metrics. We mentioned metadata a couple times. I want to define that a little bit better. Network metrics are simple things. Packets per second is probably the easiest one to think about. But then you start thinking about, well, I don't care about packets per second on my network. I care about packets per second per device. And now you've got it indexed by IP address. And now I don't care about packets per second. I care about HTTP requests per second. And that's another metric, right? So I can drill all the way down in here. And I'm indexing HTTP requests by IP address. I may actually index some various things essentially by the MAC address instead of the IP address, depending on what sort of protocol it is and where it's at in the different layers. That's all usually kind of other stuff. But at last count, we had, and I pulled this up just the other night, 4,843 metrics. And we're going to come back to that when we start talking about machine learning, because guess what? Machine learning works best when you have a lot of surface area to your metrics. So we'll come back to that. And then L7 protocol dissection. So we decode around 60 protocols. Again, HTTP, DHCP. Some of the ones that are the most popular are database protocols. So we can look at a database transaction and you can say, oh, here's your select from table, star, whatever that was. We'll go ahead and record all that. So we have all that metadata about what's happening all the way from packets per second and latency. When we started off, a lot of it was performance and it was latency. I cared about latency. Latency is not such a huge thing anymore. Most people understand their applications or they can start to get information about it. But you'd be surprised at how many times we walk into a shop and we find, oh, they've got one particular client who's requesting 100 DNS requests per second for some silly little name, localhost or something like that. And somebody goes and tracks it down and they just say, oh, we just saved a whole bunch of money that we were going to spend on a brand new DNS server because we don't need it anymore because we shut down the really dumb clients. That happens all the time. Again, technical specifics here. We do store this stuff in what's called a time series database. Don't have to spend a lot of time on that, but the really important bit is if you want to access 30 seconds worth of data or 2 weeks worth of data, it's essentially the same access time. It's very nice to have that. It's very painful to go into a product that doesn't do time series database because if you do want to look over a long period of time, yeah, I got a knot over here. That's painful. So we won't spend any more time on it. And then finally, building arbitrary graphs from the metrics. Again, 4,800 metric catalog is a lot to go through, but you never know exactly which one of those metrics you're going to want. So that's kind of an overview of the metrics. That's cool by itself. Yes, sir.
What do you do when the level 7 protocols are encrypted? Can you decrypt some of them?
I've got a whole slide on decryption. So yes, we will talk about that. So moving on, network records. A record is it's just a log. It's just this happened, a transaction of something. So oftentimes in the metric, the easiest way for me to think about this is with a metric, we don't necessarily store the select star from query, but we do store that in a record, right? Same thing with HTTP. We're not going to store your user agent, but we'll go ahead and store that in the record. And then you've got a full record of everything that happens. So you can drill down into this. And date, time, duration of a TCP flow, you'll recognize that as just net flow. So just by very nature of collecting all the data that we collect, we essentially can kick out our own version of net flow just because we can do it. So L7 fluency, I think we kind of already did some of this. The HTTP request. SMB is another big one. People really dig the fact that we can drill down into SMB and see which files and which users are accessing which files. That'll come back a little bit later too. SQL queries, I think we already covered. So the really interesting thing about this that I'm gonna talk about. Actually, let's talk about packets, and then I'll tie all these metrics and records and packets together. Packets are indexed to each flow. So if you're looking at a record, you can say, oh, you know what? I'd really like to see all the packets that happen on just this one flow. And if you've ever spent much time in a Wireshark with a great big huge gigabyte packet capture, and now you really do want to see just one specific flow, This makes that super easy to go through. Now you're downloading just the traffic that you cared about. So you can do that. So, yes?
For that kind of thing, you would have to write the packets down because, I mean, normally you only inspect the packets on the fly, you keep the metadata that you want in a depth that you need, and you discard the packets, unless you have also the packet capture.
So, sorry, the packet processing engine that we have just keeps those packets for as long as it needs to process them. We do have another device. These are all modular systems. So we do have another device that will just sit on the same network tap and eat all those packets and just store them on a great big huge disk as well. So this is a flow through. That's actually a separate appliance. And this is what I wanted to get to in this whole thing. The investigation workflow is not 3 separate devices. I'm not looking at my metrics, and then I'm not going to a separate device to look at my records, and then a separate device to pull my packets. It's all within one single, I hesitate to say pane of glass because it sounds awfully markety, but that's what this is. It comes down to one single flow where you've got, we call it automated detection, to automate your way all the way through down to the very packet level. Yeah, good question though. So.
Can I just say how satisfying it is that in the marketing team we never say single pane of glass? Now our technical deputy CISO is like, it sounds marketing, but it's a single
pane of glass. Single pane of glass. Single pane of glass. Keep saying it.
We're used to it, so
we
heard it a couple of times already.
Yeah. So obviously screenshot of Wireshark on there, obligatory. Decryption. So the really neat thing, let me state up front, essentially what's going to happen is if I've got an HTTPS encrypted TLS flow and we have all the bits to do that decryption, what you get is you get the SSL metrics, right? Because SSL is an L7, well, in this case, SSL is an L7 metric.
Sort of.
Yeah, exactly. Let's not go into details on that one. But you'll get the certificate out of it, unless it's TLS 1.3, but you'll get the certificate. You'll get all sorts of information about what's happening at the SSL layer, the TLS layer, and then you'll get all the information about what's happening at the HTTPS layer. The classic way to do this, and we've all been here, we've all seen devices like this, the classic way to do this is on your server, you have a magic RSA key, just like on your other devices that you have where you take that key and you take it and put it on another device. All of a sudden that device has the ability to decrypt all that traffic. That's worked for probably close to 10 years, something like that. There's nothing magical about that. The really interesting bit is TLS 1.3 and perfect forward secrecy ciphers, and there's a few people nodding like, yep, I've heard of that. This is just a little bit different. The green box there that says forwarder, we have a patented way to do this. Essentially, we inject a little piece of code on each server that's going to do some of the TLS, well, either side, the encryption or the decryption. And then what it does is it forwards a session key. So if you're familiar with the TLS, there's actually a session key that the bulk encryption is done with. That is forwarded to us, and then we can store that offline. Now, this gets into a whole bunch of FIPS type things and things that I'm not really going to talk about here, but I think that's really an interesting solution, partially because it's one less key from a FIPS perspective. It's one less long-lived key that you have to have, and those session keys are by definition much less valuable because their only session keys are available for only one traffic stream, and we can forget about those. So one of the classic use cases that I always talk about is I never want my CEO's laptop, whatever he's doing, I never want to save his session keys, right? I think that's kind of a silly example, but I think that's a good way to kind of lead into it and say, this is something that I may want to have. By policy, kind of a policy guy here, I may want to architect a policy like that. So
what you do is basically have the server send you the session keys, and you can configure the session keys that you don't want to get?
That is correct, yeah. Yeah, okay. So you can send them all, and then what's really nice, we talked earlier about the packets and getting the packets and how the click down through. You can essentially push a button in our GUI that says download the PCAP-NG that includes the session key right along with it. Wireshark 3 has that ability, and it's embedded now. We actually submitted some of that code back to Wireshark.
Oh, that's from you? Okay.
Yeah, that came from us, yeah.
I'm on the PCAP-NG development council, so.
Cool.
That all goes to me all the time.
Yeah, I only recently learned about the block-based nature of PCAP-NG, so I had to think about it when we were developing it. So, cool, excellent.
So now you're dealing with session keys.
Correct.
Many regulated industries require those to be protected. So is now ExtraHop actually going to be tied, since you're going to be storing those, are you going to be tied to an HSM in some way?
So we do not currently have HSM support. I've done a lot of work with the HSMs. We've always been open to it. We just don't currently have support for HSMs. What we've always gotten around is saying the long-lived RSA keys certainly belong in an HSM. These shorter lifetime session keys don't necessarily need to be in an HSM.
It's actually protecting the session keys, so you need a way to store the session keys in an encrypted format that is protected on your device. That's what needs, that vault, so to speak, needs its own key.
That's correct. Without going into too many details, we actually have encrypted storage on our device where we store those particular session keys.
Yeah, but that's what needs the HSM support, not the session keys themselves.
Side note: I'm actually I quite like some of the new PKCS 11 and Net HSMs and some of those.
Yes, I do too.
That would be the way that I would go when we get all this built up. We've done some investigation on it. We just haven't productized it yet.
Okay. Yeah. Thank you.
Great, good discussion. Okay, so continuing in our nerdery here, event-based domain-specific language. We call them triggers. It is JavaScript. It's what everybody embeds these days. It's event-based scripting, and when I talk about event-based, it's essentially when an HTTP request happens, you can register for a callback, and your code executes when HTTP request happens, and you can go ahead and extract out, if you'd like to. But the example that I have up here is a pretty simple little example of looking for HTTP user agents. And if I see a user agent that I don't like, NCAT test or something like that, mass scan, these are some common user agents that may or may not be lying, but we can notify on those sorts of things. So this was just a simple example that I pulled. At the top, we've got a list of user agents that we don't like. At the bottom, we've got a little bit of code that says, hey, let's alert on this and let's do something in our GUI. And we'll get to a demo, and I can show you what the detections look like. I like this. What I think this does is this sort of future-proofs us. So if you don't have some information in one of your protocols, or we don't have any information, you can go ahead and extract out that information with a trigger, and then we'd have that information, right? You can start indexing that, and you can put it in. It goes into our regular metric catalog. You can build regular common records with it, so you can go ahead and extend the functionality of the product arbitrarily.
Hey, Jeff, do you mind if I just comment on that? One really cool thing about that kind of trigger engine and the ability to kind of create ad hoc support is that we end up doing a lot of prototyping that way, almost by accident. So a customer will say to us, like, we're using Modbus in our SCADA environment. Do you support that? We're like, yes. And so then we kind of create the protocol support within this domain-specific language, and then eventually bake it into the product. So it allows us to kind of rapidly iterate on the technology we support.
Yeah, that's been very successful. I run our threat research team. And just recently, just in the last few days, there's been some interesting RDP happenings. There's been some interesting the selective ACK that happened in the Linux boxes. These are all things that we can essentially write triggers for and detect quite easily. So a lot of success there. That's why I like the future-proof term on that one. Okay, so machine learning. Again, it seems like everybody's talking about machine learning. The points that I want to hit here are a couple of them. First of all, machine learning works really well when you have a couple of things. First of all, when you have a lot of shape to your data, when you have a lot of aspects of it. I like to think of it as purchase area for or surface area rather, for the machine learning algorithms to kind of bite into and extract information and build models of these sorts of things. So if you think about that for a little bit, I mentioned a number 4,843 a little bit ago. That's essentially the surface area. If there's one thing that I would have you take away from this whole entire talk is, if you're gonna do machine learning on something, think about the veracity and the quality of your data in the first place, and what in those algorithms that you can apply to it. That would be the thing. And then the second aspect of that I'd like to go into is machine learning obviously works better when you have large masses of data floating around, and then you have plenty of compute. And this is where I start to bring up, okay, so if you think about large pieces of data laying around and plenty of compute power, that sounds like the cloud. So that's exactly what we thought about a couple of years ago, and we said, how can we do that? How can we get a subset of these metrics that we've already collected up to the cloud where we can run plenty of compute across them? Because we're already spending all the CPU that we have on your network, picking apart packets. Yes.
But I've been waiting for you to finish your sentence.
Okay. All right. Well, let me finish on that.
Yeah.
You get all that compute, and you start running those algorithms on it. And that's when I started to think, well, okay, we're sending a whole lot of data up to the cloud. How can we architect this for privacy? And we did talk about this a little bit ago. Is this where your question was going?
Yeah.
Yeah, okay. So I personally went through each and every one of those. At the time, it was like 4,700 metrics rather than 48. I think it was 46, but it doesn't matter. And I tried to figure out how I could do that. And essentially, if it's a number, packets per second, I don't really care about the privacy of that. But if it's packets per second per IP address, I certainly do care about that. And the solution that we came up with is actually quite simple, and I don't know of anybody else in the market who's doing this, and I'm very pleased with this. Like I said, I'm very proud. Essentially, all we did was we used a deterministic encryption algorithm. So we generate a key down here. This is on the customer premises, the green box, and then the blue box is the cloud. We generate a key down there. It's unique to each individual box. When we send an IP address up to the cloud or anything, possibly we might send an SMB file name, right? Because we can pick those out. We may send a SQL query, something like that. We don't want that. We can go ahead and do the deterministic encryption, run our machine learning algorithms, because the machine learning algorithm just wants to know that 10001 did something over and over again. It doesn't really care about 10001. It just cares that a unique identifier did this a certain number of times. So that's how we do that. Like I said, I don't know of anybody else that's done it. I've been very pleased with the results of it because we can do really interesting things and we can still sign business agreements or something that says that, we don't have any of your data in the cloud. That's a huge market differentiator because the risk of something like that, we've also done some other things in here, architecting for privacy. So even if somebody did breach one of our customer instances, they can only get essentially simple metrics, and they don't get any real information for it. So I'm very pleased with that. I think this is a huge market differentiator. Happy to take questions on this. I think this is.
So you're basically tokenizing.
Basically tokenizing it. I did a lot of investigation for tokenizing versus deterministic encryption. We determined deterministic encryption was better, but tokenization would be the proper word when you started to talk about it from a GDPR or HIPAA perspective.
But deterministic encryption also means that it has a deterministic, I can find the key. That's what that means to me. So if you have a deterministic encryption, that means you have a way of decrypting it up in your cloud. That would bother me.
I don't have the key in the cloud.
Yeah,
so
but deterministic means it's a deterministic key to me.
You are correct.
But that's the problem.
We can look.
We're not going to spend the compute power to drive your key, first of all.
Well, you may not.
Well, we may not. That's a good point. Yeah. Well, but I should also say though that the tunneling upstream and downstream to that cloud service. At first, I thought it was over-engineered for privacy. You just told me we've got 9 different tunnels and stuff, but it's to protect against exactly that kind of thing, right? We've made it very mathematically difficult. Honestly, the types of organizations that would spend the money to do that probably just beat us up with a rubber hose anyway, right? I'm just kidding. Rubber hose cryptography? Anybody? No?
ACD
reference didn't land?
Yeah.
Okay, well, whatever. I actually got up not to make bad jokes, but to point out that my engineering background compels me. That should say TLS 1.3 on that slide. Just had to point that out. We have full support for TLS 1.3.
And all of that on the marketing side is
actually,
probably the design team that
there you go.
wrong number
Take
in
the
there,
bullet.
so I'll take the bullet on that one.
You have 9 different tunnels?
No, 9 was an exaggeration. I'm not going to share the exact number, but it's let's just say it's more than 2 and less than 7.
I would love to know more. Interesting.
I'd be happy to have that discussion with you when we're not live streaming on the internet.
Yeah. Yeah.
What else have you done to, other than effectively tokenization?
Effective tokenization, sorry to interrupt your question.
And ways to get in and out of your service, what else have you done for privacy?
There's always a logical separation between every customer. In the cloud service that we're using, we've got separate volumes for each and every customer. We don't mix customer data. So,
Okay, what else?
Yeah.
And I mean, I think the proof in this is the customers that have adopted it that have those same kinds of questions. I mean, we're talking about like Fortune 100s, Fortune 5s, right? I mean, so if it passes their muster, I mean, maybe that gives you a little bit of sense of the type of rigor that they have and how we've engineered it. I hate to be a jerk about it, but I also enjoy being a jerk.
I maintain a document called our Security, Privacy, and Trust document, which is aimed at answering all these questions in our publicly available form, and that's where I would refer to.
That's fine.
Yeah.
To me, it does seem like when you stated it's got all of these privacy controls and that, I mean, to me, it sounded like you basically followed the requirements of GDPR, which is privacy by design, like controls from conception of the idea. So, I mean, I like that. That sounds really brilliant. But I think if you want something really, really, really like detailed, that's kind of a read the documents question.
Yeah, it is. I just was hoping they could share more.
There's some secret sauce there. We are definitely using this as a market differentiator in places.
Oh, definitely.
Yeah.
And I'm glad you mentioned GDPR because in some cases in the US, we can kind of end questions about this just by saying it's GDPR compliant. And they're like, oh, okay. You know what I mean? So.
Okay.
Just to pile on that, when we architected this, GDPR was still a little ways away from full implementation. We're only a year and a month past that, roughly. HIPAA was, of course, HIPAA's been around for 30 years, so there was some HIPAA design as well as GDPR, and CCPA wasn't even, at the time, there was no CCPA. So CCPA is another interesting thing. I've had some recent discussions about that. So. Anything else we'd like to talk about on this one? The anomaly detection. We didn't spend any time on machine learning algorithms or anything like that because you've all heard all those. So I don't need to spend too much time on that.
Jeff,
Yes.
would you mind talking a little bit about why we care so much about being able to decrypt traffic?
Why we care so much about
Yes,
being able to decrypt?
why we think that that's important?
I think it's important for visibility to have. Essentially our L7 fluency is some of the greatest magic we have, right? The ability to drill down into that and say, oh, this is what the SQL query looked like. So the ability to pick apart and get all the way down in there. You can pull up the Firefox HTTPS TLS usage chart, and the last time I looked at it, it was reaching 70 to 80% of the traffic on the internet was TLS, which as a privacy and security advocate, I'm totally thumbs up on that. That's the interesting bit is we're seeing more and more of that, and so that's why I wanted to bring up the decryption, the capabilities that we have.
When it comes to non-HTTPS based protocols, I mean, even MySQL could be encrypted. Do you decrypt that as well? And how does that work?
Yes.
Mechanisms could be different than having the session key.
So we've selected a certain number of them. For example, LDAP has an LDAP-S, which is effectively start TLS. It's an OID-based thing, but it's effectively the same thing. SMTP has the same start TLS functionality. Those two are two that we definitely do. We usually get asked for HTTP and HTTPS. Frankly, it's not hard to hook up SMTPS or...
Because you just mentioned encrypted database traffic that you're looking into, and that made me assume that you can decrypt that one as well.
Yeah.
So I don't know for sure that this is why Rachel brought this up. And that she wanted me to sort of complain and make fun of our competitors and other vendors, but I'm easily provoked.
I did not say
okay.
that part.
Nope, but I'm doing it anyway, so here I am. So the thing that kind of kills me is somebody who has, I'm certainly no crypto expert, but I've certainly dabbled in my day. I implemented my own SHA-1 for the fun of it, a bunch of years ago and stuff like that. A bunch of vendors in this space are trying so hard to convince the security community that being able to decrypt traffic for visibility doesn't matter, which is hilarious to me. And they go to these lengths to say yeah, no, you don't have to decrypt because it's like a Christmas present that's wrapped, and if you shake it, you can listen to it and find out what it is. Which, number one, no, you can't. That makes no sense. The analogy doesn't hold up. But then, the idea that the thousands of years of math that go into hiding things isn't important in a security context, or to use your SQL example, knowing the difference between something that's obviously SQL injection or encrypted traffic, like it just drives me nuts. And so I take every opportunity to make that.
There are a couple of ways where you can look at encrypted traffic and still deduct what might be in there to a certain degree, but it's not the same depth, of course. So
Exactly.
if
It's
anybody
certainly-
says it's the same depth, that's just
And yeah, there's some techniques, great, but isn't it better?
it's better. Yeah, but
Like, to
it's
decode
more
it?
complicated.
Yeah, so it's not like there's nothing else you can do. It's just that when you say it doesn't matter, or it's not obviously better, that's the part that really makes me crazy.
What's
Anyway.
really interesting about that too is usually what they say is things like, oh, JAW3 allows us to, if you're familiar with JAW3, it's essentially an SSL fingerprinting technique. We built that in almost 2 years ago now. Well, no, it's not, about a year ago now already. So we have those sort of fingerprinting, we have those same techniques available to it. It's actually quite powerful. I kind of like, we're messing around and seeing what we can do with JAW3. So we have some of those same techniques. We also have the decryption.
So do you have a reference architecture on the best way to implement ExtraHop when you're doing all this decryption? Because that itself, if people do it, which is acceptable from a security monitoring perspective, you have to because it's a visibility. But if you have a really bad architecture for implementing it, it just puts you yet another attack surface.
Yeah, so first of all, I will say that good architectures start upstream of a reference architecture. In other words, if you're not designing your product components to minimize like mishaps, right, and things being put together in the wrong way, you're kind of doing it wrong. Our co-founders are sort of mad scientists in that way, and they think very carefully about that. So that kind of capability starts very upstream in the development process and the product creation process. To that end, though, yes, we have reference architectures for a lot of different things you might want to do, including the decrypt, including hybrid cloud, including ... right? So yeah, absolutely, and also experts on hand to help.
Are those publicly available for people?
I don't know which are and which aren't. I would have to go look at that. I'm a bad marketer, I guess. Not we have it on the internet, but yeah. We certainly have them on hand for customers and for anyone who wants to discuss them with us.
Yeah, I'd be very interested in anything for decrypting SQL traffic, specifically like SQL Server, Oracle. They offer products like TDE, so I'd like to know what your preferred or what your advised method would be for configuring it.
Yeah, and unfortunately, it's going to depend on the specific version and cipher suites that you're using and what particular era of Windows reference architectures you're using.
This is why he started a professional services team, by the way.
Yeah, exactly, right. It's to like help people figure this stuff out because it's pretty complicated. I couldn't tell you the exact details of TDE, to be honest with you. It's a matter of generally speaking, it's a matter of keeping up with the standards that the OS and platform vendors are setting, and we're trying to stay ahead of that. We're fortunate in the case of Microsoft, AWS, /Amazon, and GCP in that we're headquartered in Seattle. So if we want to find out where they're going, we just drive or walk 3 blocks, right? So we're trying to stay ahead of it that way. Does that help? And we can talk more in detail about it if you like.
Yeah.
I have a question. Are you like, whenever I talk to vendors that are like, oh, we decrypt all the traffic and then we, is there any consideration about bottlenecks, or is it based on the fact that you're using the cloud, you're expected it will ramp up as needed and go down as you need it?
You're talking about a bottleneck in performing decrypt itself, or?
Yeah, just in being able to like I've seen such badly created networks that I'm like concerned in their capability to survive this. Oh,
okay. I see. You mean in terms of the upstream and downstream that's going back and forth from our cloud service?
Yeah.
I mean, it's such a small subset of the data because it's nowhere near like full packet streams or even flows or whatever. We're taking out metadata based on sort of more trend information and then de-identifying that. So it's a really low volume of data. It's not even something you probably notice on your network bill, much less kind of be bottlenecked.
Yeah, fair enough.
Yeah.
Okay.
And we kind of prove that out, right? Because our whole deal is we measure networks. So if a customer wants to know how much stuff they're sending upstream to us, they can just check our stuff and see what's going on.
And to put it in context, just to sort of give you a sense of traffic difference, right? We showed those screenshots of this vendor is pulling out a terabyte of traffic over 2 days. When ExtraHop sends this data up to the cloud, it looks, and sanity check me on this, but the last time I talked about this with our product team, it looks like about like you're streaming a Netflix.
Okay.
Like, it's not a huge amount of data because it is the metrics and not a vast quantity of
Well,
packets.
It's a subset of the metrics as well. It's the last guidance that I can remember was around like 1%. So if you've got a 100 gig network, it's way down in there. So yeah.
So actually, I think
know, I'm
that
sure-
that
yeah.
streaming Netflix comparison applies more toward our absolute largest and most scaled out customers, who are huge, right? Our average customer, because I've run these numbers myself for funsies, and I did the range of 2 to 7. I'll give you another range. Ready? So it is more than the modem I was using to connect to BBSs in 1993, and less than the one in 1998.
I'm a bit young for
1998,
that
yeah.
reference, but I get it. I see the next bit is demo, which sounds really exciting. So I will hold that quite. I'm basically want to see what essentially I would see if I was managing this, which I imagine you're going to demo. So
That is exactly what.
okay, then I won't bother asking.
Yeah, let's just jump into that. So
And real quick, before he demos, that link that you all just saw there is a link to our live interactive online demo. It has both security and performance scenarios, so you can actually go play with this yourself.